Salutations, my name's Abirita Nathaniel Morashilalahi. I'm the partner of Bagas and we will be presenting about three main topics from our math textbook. The first is geometric transformation, the second is the quadratic function, and the third is definite integrals. I hope you enjoy. Hi. Firstly, I'm going to explain geometric transformation with matrix manipulation. So basically, we use geometric transformation to change the position or shape of a point by multiplying with matrices. So, for example, point A can be written as A. Point A can be written as AB. So for basic translation, we will just add it up by 1. Let's say, for example, 1 comma 2. And that will be A plus 1, B plus 2. Simple as that. So next, dilation, rotation, and reflection. First, dilation, we will multiply the point by a factor of k. The formula for this is k 0, 0, k. Multiply it by a and b. Next, what is rotation? Rotation turns around a fixed point, usually the origin by a certain angle. So the formula form is cos x sin x min sin x cos x, and multiply by a and b. So what is reflection? Reflection flips a point over or a shape over an axis or a slash line. I would just present two today, like y axis. I guess the y axis, which is min 1 0 0 1. Multiply it by a and b. And the x-axis, which is the reverse form of the formula, which is 0, oh wait no, 1 0 0 min 1 and b. So we will now do an example question for geometric transformation. So point A is 2.4, which is 2, 4. First, we'll dilate it by the k factor of 2, which is 2, 0, 0, 2, which is, we will get the result of 2 times 4, and 2 times 2 is 4, 0, 4 times 0 is 0, and 2 times 4 is 8, which we will get, for 8. Next, we will rotate it by 90 degrees. So first, we will put in cos 90, sin 90, min sin 90, cos 90. Multiply it by 4 comma 8. So this form usually goes to 0, 1, min sin 0, which is 4, 8, which is equal to 4 times 0 is 0, 4 times 1 is 4, 8 times min 1 is min 8, and 0. So we would get min 8 and 4. Next, we will reflect it towards the y-axis. The y-axis uses the min 1, 1, and 1 form. Multiplied by min 8 and 4, which is min 8 times by min 1 is 8. Min 8 times by 0 is 0. 4 times 0 is 0. 4 times 1 is 4, which we would get a final answer of 8.
Okay,
4,
so
which
now
is
I'm going to
the
talk
same
about the
same as
quadratic function.
8 comma 4.
So the quadratic function has two general formulas, which the first one being the ax squared plus bx plus c equals y, and the second one being y equals a x minus h squared plus k, These two forms are equivalent to each other because the fact that when we squared a plus b, or say we squared x plus c, where c is a constant, and then we squared, we got x squared plus 2xc plus c squared. So we got the second order, the x squared. We got the first order, the x times 2c, and we also got the zeroth order, which is the c squared. Okay, so we can change one formula to the other. Say we want to change the ax squared plus bx plus c to the ax minus h squared plus k. Notice that when we square x minus h, we got x squared minus 2xh plus h squared. And then we multiplied all of this by a. We got ax squared minus 2ahx plus a h squared, and then we add it with k. We got the form similar to the first one, the second one. K, y equals ax squared plus bx plus c. All right. And then the next thing we want to do is to match the coefficients for the respective power of x. So this is from the equation 1, this is for 2. So a equals a. This is for the x squared term. And then b, for the x term, b equals minus b equals minus 2ah. And then the third one being c equals, this is for the x zeroth order, by the way, c equals a h squared plus k. All right. So for the example over here, we have this equation where we are asked to convert the equation of minus x squared plus 6x minus 5 to the vertex formula, which involves x minus h squared. So we define the a first, which is minus 1 from here, b equals 6, and c equals minus 5. So from this here, we got that h equals minus b per 2a. Thus, h equals minus 6 per minus 2, which we got equals 3. And then for the k, k equals c minus ah squared. So k equals minus 5 minus 1 h squared, so it equals 9, because 3 squared is 9, equals 4. So we got minus x minus 3 squared plus 4. Yes, plus 4. So this is these two function is equivalent with each other. For the second part of the quadratic formula theory, I'm going to talk about the maximum point, maximum or minimum point. Sorry. So, a maximum or a minimum point of an equation, a quadratic equation, with the general formula of a times x minus h squared plus k is reached when x equals h. So a maximum or a minimum point of a quadratic equation is a unique point which can only be found once in all of the x domain. So it is when x equals h, so that the term here in the bracket equals 0 when x equals h. So y equals k. Imagine if x equals h plus 1 or x equals h minus 1, then when we minus both and then we squared it, we will get 1. So 1a times k. So we got two values of x which produce the same value of y, thus it is not a unique value. Okay, back to the original problem. Fx equals minus x squared plus 6x minus 5. This is still not in the vertex formula, so we convert it first. We had already done that in the first part, which equals to minus x minus 3 squared plus 4. Now, x equals h, so x equals 3. The term in the bracket becomes 0, and we got the maximum point, maximum or minimum, sorry, equals 4. Now, how do we know that it is either a maximum or a minimum? Well, we look at the coefficient a. So if a negative, then the graph will be shaped like this. This is the x-axis, this is the y-axis. So the unique value becomes the highest value or the maximum. If a equals positive, the graph will be shaped like this, or like this, or like this. Depends on the ABC value. So the vertex is a minimum. We can see here that the a is negative, -1 to be specific. So this is a minimum point. Sorry, my bad. A maximum.
We're going to explain definite integrals. A definite integral measures the net or total area between the graph and the x-axis from x to b, from x equals a to x equals b. So the general form will be a integral b small fx dx, which is in turn going to be big X, not really big X, but big F B minus F and big F A. Yes, precisely like this. And in turn, it's going to look like this when you put it into a graphing calculator, or once you draw it by hand.
So now I'm going to do the question for the definite integral. So the question is like this. Sorry. Find the area of graph. For the specific area, it will be from x equals x1, which is the first x with the curve being 0, and x2, x equals x2. The second x, which the y values for the curve is 0. And then we want to sort of find the area between these two graphs. So we are actually going to subtract the area of the line minus area of the curve, because this is the area of the curve and the area of the line is the total. So this white area is the difference between the line and the curve. Okay, so we need to find x1 and x2 first from the equation of this. X minus x squared plus x 4x. Well, we can factorize the x becoming x minus x plus 4. So x equals 0 and x equals 4. This is x1 and this is x2. As for the line equation, it is y equals to x plus 1. So we do the integration to x plus 1 minus x squared plus 4x dx. Got integral of x squared minus 2x plus 1 dx from x equals 0 to x equals 4. Remember the integration rule, the power of the x plus 1 and then becomes the denominator, equals x to the power of 3 per 3 minus 2x squared per 2 plus x power of 1 per 1 evaluated from 0 to 4. Well, obviously, for the x equals 0, this whole formula becomes 0, so we need to only evaluate at 4. 4 to the power of 3 is 64, minus 2, the 2 cancels, 16 plus 4 equals 64, per 3 minus 12 equals 64 minus 36 per 3, 28 per 3. And so with that, I, Bagas and my partner, Nathan, we both have successfully covered 3 chapters from the mathematics book, which are the definite integral, geometric transformation using metrics, and the quadratic equation. Thank you for watching, and thank you.